All right, I'm going to introduce you to the complex plane. This is still between like with polar and rectangular coordinates, but now we're going to deal with imaginary numbers or complex numbers, which you may be thinking, oh, I thought we were done with that in college algebra. Not so much. So some of these conversions you'll recognize. These ones down here are big ones that we just used in our last section and in my last video. These are the main ones I want you to remember. But now we are converting with these two forms. So here we have our real or our complex rectangular, and here we have complex polar. And yes, that is our famous little letter E called Euler's constant. But we're still finding our X, our Y, the thetas, the R's kind of in the exact same way. It's just how we write our answers that are going to make a difference here. So I'm going to seal that. All right, so we're going to convert these to polar form, which means, and it does say exact. That's the fun part. Let's see if I can find, I need to find our unit circle because that is the thing we need to have here. I'm not seeing that handy right here, but we'll find it. I'll get you a unit circle here so we can look at that. All right. Convert to polar form. That means these are in rectangular form right now. So a couple things to remember. Our X right now is -1, and our Y right now is a +1. There's an I here, which means there's an implied 1. And so we are going to convert these. And remember to find our R squared. We do X squared plus Y squared. Lost my phone. There we go. And we can do that easily here. So our X squared plus Y squared. So -1 squared is 1, and then 1 squared is 1. So we get our R squared to be 2. Which means that R is the square root of 2. We want to keep it exact, so we're going to keep it like that. Then we're going to use tan. So tan theta equals, remember, it's y over x. So tan theta equals -1. Now, here's the nice thing. If you are going and working in degrees, your unit circle is not that big a deal because you can actually just type it in the calculator and get values here. But I can show you on a unit circle where these are located. So it's not super, super confusing. See if I can pop up a unit circle that's a nice one here. So I'm just going to pull this over here. It's a whole bunch of unit circles. But looking at this one right here, we can also see that to get -1, that means sine divided by cosine has to be -1. And we're looking in these two quadrants. Well, here it's +1 and here it's -1. So it's actually this angle right here, but we're going this direction. So it's a -45. If you would just type that into the calculator, so sine inverse of -1, guess what? You get -45. So either way is okay, but in this case, our theta is -45 degrees. Now, if you recall our form we write this in, that's where it gets a little bit trickier. So we are going to write this in, I'm going to write it up here. So this will be r e to the theta I, all these forms. So our r was square root 2, so we'd have square root 2 e, and then we've got a -45 degrees times I, and that's our answer there. So let's try this one. So r squared is going to be 1 squared plus square root of 3 squared. Well, square root of 3 squared is just 3, so 3 plus 1 is 4. So r squared is 4, which means that r is 2. These graph the same way as the others, just so we're aware. I want to make sure everybody understands how we're knowing whether to use sine, cosine, tangent, all that kind of stuff again. Quick review. Graph it as if it's an x and a y. So -1, 1, which means we actually did this one wrong. Our angle here anyway. So negative 1, 1 would be over here. So how would this one get fixed? Think about it. Think about where we had things last time. Remember, this one could be any. This one was using cosine. This one was using sine or tangent. This one was using cosine and then make it negative. So what should we have done over here? Well, we should have used cosine. So let's try this again. See, even teachers make mistakes, and it is okay to do that. All right, so instead of using tangent, we want to use cosine. And that's on our other video that wasn't on necessarily this one, so hopefully you watched the first video first. So cosine of theta is our x, which is negative 1, over our r. You should still be able to type this in the calculator with absolutely no problem. It would still be second cosine of negative 1 divided by the square root of 2. And guess what? We still get a nice number. It's 135. So theta equals 135 degrees. So the only difference that we have here, because our r didn't change, is that up here we have 135 degrees. All right, back to this one now. So we found our r. Now we got to figure out where this is at. So 1, so our x is square root 3, or sorry, our x is 1, our y is square root 3. So we're positive, positive. So we're up here. So I would say, yes, let's use tangent here. That makes life a little bit nicer. So tan inverse of y over x. So square root 3 over 1. You can use your unit circle, or you can use your other functions as well. So that is entirely up to you how you want to go about doing that, using your calculator or using the unit circle. But either way, we get theta on this one to be 60 degrees. That means our answer, I'm going to write it down here where I have some space, is going to be 2e to the 60 degrees I. Now over here, it says round to 3 decimals. So we can find our r. Throw a whole different color in here. So our r is going to be negative 3 squared plus negative 7 squared. So 9 plus 49, and then the square root of that. So our r to 3 decimals will be 7.616. All right, negative 3, negative 7, negative 3, negative 7. So we're down here. So we're going to use cosine again. So cosine inverse of our x over our r. And then we're going to make it negative. I don't know what that was. So theta equals a negative 113.2 degrees. So let's write our answer in form. I'm going to put it up here above because I'm kind of running out of space all over this page. So 7.616 e to the negative 113.2 degrees I. So there's our exact form on that one. Or our approximated form, but there's our answer. Okay, so once again, going from rectangular to polar is a little bit more work. Going from polar to rectangular, so much easier. Now, this does want exact, so we will have to look at the unit circle here. All right, so keep in mind, r is square root 2. Theta is negative pi over 4. So if we're going exact, we also know that x equals r cosine theta and y equals r sine theta. So let's see if I can get a Nice unit circle. Oh, here we go. This one's really nice. Okay. Let's pop this over here. So our r was square root 2, and our theta was negative pi over 4. Well, negative pi over 4 is down here. Well, cosine at negative pi over 4 is square root 2 over 2. And sine at pi over 4 is negative square root 2 over 2. So those are both easy to use here. So x equals square root 2 cosine of negative pi over 4. So if I were to write all this out, this would be times square root 2 over 2. Well, square root 2 times square root 2 is 2. 2 divided by 2 is 1. All right, and then our y is still r times sine theta, which we got our sine of pi over 4, negative pi over 4, to be a negative square root 2 over 2. Well, square root 2 times square root 2 is 2, divided by 2 is 1, and then a negative. So this would be a negative 1. So x is 1 and y is negative 1. So the way we write our answers, up here is we will have x plus y I. So remember, our x is 1 and our y is negative 1. So instead of plus and negative 1, I'm just going to do minus 1 and then I. You don't even need that 1 if you don't want to. Could just be 1 minus I. All right, do the same thing. Let's see if you can figure this one out using your unit circle again. So you may have to pull that up or find one on YouTube or on the internet, but let's see if you can figure this out. And I'll put the answer that looks like this underneath it, and then you can check your work as you're going. Okay, so here's the answers that I got. I got x to be negative 3/2, and I got y to be 3 square root 3 over 2. So you would write your answer either like this, or you could write it like this because they do have common denominators. So that's up to you. All right, this one's easier. You just type it in the calculator. Remember, x equals r cosine theta, y equals r sine theta. So once again, try this one and see what you can come up with. Well, how'd you do? You think you did all right? My question to you is, if you didn't get those answers, what mode were you in? You should be in radians here. Notice the degree symbol is missing. So this is actually a theta that's in radians. So make sure your calculator mode is in radians when you do this calculation. If you need to pause and try again, feel free to do so. But this is how we convert to rectangular form. So once again, converting to rectangular form I find much, much easier. All right, and the last thing we're going to do is find a product and quotient. This is a fancy way of using our properties of exponents again. And by product, I mean we're going to do what is z1 times z2. So what is 8e to the 50 degrees I times 4e to the 30 degrees I? Well, we multiply them and use our properties of exponents just like we normally would. So 8 times 4 is 32. When the bases are the same, we add the exponents. If I keep my base, 50 plus 30 is 80 degrees I. That's our product. Then to find our quotient, we're going to do z1 divided by z2. That means ae to the 50 degrees I divided by 4e to the 30 degrees I. So divide. 8 divided by 4 is 2. And if that doesn't come out nice, write it as a fraction. And then what happens when I have the same base and I'm dividing? Well, you should subtract the exponents. So 50 minus 30 will be 20 degrees I. It is okay to have negatives in our exponents right now. If you end up with like pi over 2 and pi over 6, leave them in terms of pi. It doesn't matter. But that's product and quotient. You're going to leave them in polar form. And that is probably the easiest problems that you will encounter on this homework. So that is everything dealing with the complex plane. I hope that helped you, and good luck on your homework.